Hello, academics. Today we are going to be learning about our sixth lesson of the series, and it is average rate of change. It also is otherwise known under the acronym of AROC. I call it AROC, some people call it other things, but I just like AROC. Um, and before we start, let's just understand a simple principle. Let's say we have a function that's just a regular parabola. If we want to find the average rate of change between 2 points, we want to find the secant between these 2 points, which happens to be the straightest line possible. This in turn is our average rate of change, whatever the the slope of this, often represented by m, is. And so to do that, we're going to use a concept that we've already learned, which is if we have point, let's say, there and there, the average rate of change between these 2 points can be determined through the equation of the n is equal in the change of y over the change of x, otherwise known as rise over run, right? And we know that equation is also y2 minus y1 over x2 minus x1. And so for that, for example, this is point 2, this is point 1, this is x2, y2, and this is x1, y1. And then we just plug those in into the equation and get it solved. So for example, here it would be that is 8 minus negative 3 over, and that would be 6 minus and negative 6. So that gives us 11 over, that is just a regular 6, not 16, over 12. That is our slope. And we can apply this to a polynomial function. So for example, we have the function here. It's if we want to find the rate of change between, let's say, point 2 and point 1, we need to find its rise over run. But the problem is that if we are just given a function, it's a little more complicated to figure out the coordinates of each point, right? So instead, we know this is function f of x, right? And so let's say this is point, instead of 2 and 1, let's say b and a, right? The coordinates of that are b, because this is b, and then, or we can put little b, and then f of b, because the y will be equal to f of b, which is the y at the point b. And the same thing can be said down here. So this is a and then f of a, just like that. And so in this formula, instead, we can write the equation of f of b minus f of a over b minus a. And that's just a more clear and simple way when we're talking about polynomials. But again, let's put in, instead of m, our AROC, and then b minus f of a, just like that. And that is how we got our function of the average rate of change. It's just that simple. It's just our initial function of y2 minus y1 over x2 minus x1, just in a more applicable way to the course that we are learning at the moment. So let's do an example of that. So let's put 2 well-defined points on this graph. So let's say here and there, right? So this is x equals 2, and this is x equals negative 1. So our average rate of change, and sorry, this is, the function here is just f of x equals x squared. So our average rate of change will be fb minus fa over b minus a. And so for that, we have f of 2 minus f of negative 1 over 2 minus negative 1, which gives us 4 minus 1 over 3. So that just gives us 3 over 3, which just gives us an average rate of change of 1. And we can draw that in there, and we can see this is pretty bang on. That is, in fact, an average rate of change of 1. But yeah, so that's it for the lesson. Pretty simple, pretty straightforward. If you have any questions, feel free to leave them in the comments. But other than that, I hope to see you in the next video, and have a great day. Thank you.